Okay, so now we're going to look at common data types in Python. You can get into the weeds here and talk about different types of numbers and how they're defined based on the number of bits that are used or whatnot. We're just going to stick with the major broad data types for now. We will talk about some other data types later, especially when we look at like NumPy, because it introduces some new options. Okay, so any programming language needs to be able to store or manipulate or use both numeric values and also strings or text. So if you provide a number that is not put in quotes, then that's going to be interpreted as numeric data, and then you can perform numeric type operations on it, like addition, subtraction, division, whatever. So in this example, that's what I'm doing in this first block here. So x is equal to 1. I'm basically x is associated with the numeric value 1. The type function that's used to that's used to return the data type. So it'll tell you what the data type is. Here I'm converting it into a float, and here I'm converting it into a string or a character string. So if I run this, you can see how that works. Basically, we create a number. It's initially an integer. I use the float function to turn it into a float, and then I use the string function to turn it into a string. So let's just play with this in a little bit more detail. So first off, if you provide a number that doesn't have any decimal places, then the default is that that's going to be stored as an integer value or a number with no decimal places. So we can see there it returns int. Now, if you want this number, even though it's a whole number, to be treated like a float number or a number with potential decimal values, there's a couple ways to accomplish that. One option is you can just simply put a dot on the end, and then that'll return float. Right, so it has decimals. You can also do .0, though that really doesn't add anything past just including a dot. So again, there we can see that that's still float. And another option is that you can use the float function. Okay. Anytime you create a value that already has a decimal, like 1.2, then it's automatically going to be a float. You don't need to declare it as a float or set it to be a float. Let's see if you take a float number and you convert it into an integer. So to do that, we do y is equal to int of x, and then we'll just print type of y here. And let's also print y. Oops. Okay, so, sorry, I guess I need to wrap these in print too. There we go, we get everything printed. Okay, so here we can see that x is float. And then when we make y an integer version of x, it's just rounding it off to 1. And then if we print the type of y, then it's an integer, which makes sense. Let's change this to 1.8 and see what we get. So here we still get 1. So note that whenever you convert a number with decimal values to an integer or a whole number, it's going to round down. So that's an important thing to note. All right, so let's just look at some operations that can be performed on numeric type data. So here's just a few examples, and I just want to make a point here about the difference between data types and why it matters. So here I'm creating a new variable x and setting it equal to 1, and then I'm creating y and also setting it equal to 1. But this time 1 is in quotes as opposed to not being in quotes. So if I then print out the sum of x plus x and y plus y, we actually get different results. So the first one here, x plus x, that's basically 1 plus 1 yields 2, right? So it basically did addition type arithmetic. However, for the second component here, the one with the quotes around it actually is a string. So this is being treated as if it's string or character as opposed to a number. So using the addition time here doesn't add the values, but it actually concatenates or pushes the strings together. So this would be the same as doing something like this. If we did, let's see, x is equal to data space, and y is equal to science. And then print x plus y. Oops, forgot my quote there. Note also in Python that single quote for strings, single quotes or double quotes will work. Okay, so anyway, that just concatenates those two strings, and I included a space in the string so the words weren't ran together. So that's effectively what was actually going on up here, because one is the string one as opposed to the number one. It gets concatenated as opposed to being added. All right, so in short, how data are defined does matter. Okay, so in this next example, these are just the types of mathematical operations that you can perform on numeric data, and these are actually similar to what we talked about above with the assignment operations, except we're just not part of an assignment, it's just the operations. So plus is addition, minus is subtraction, asterisk is multiplication, / is division, percent is modulus or remainder after division, 2 asterisks is exponentiation, and then 2 / indicates floor division or rounding down to the nearest whole number. So let's see if this makes sense. So 4 plus 3 is 7, 4 minus 3 is 1, 4 times 3 is 12, 4 divided by 3 is 1.3. If you divide 4 by 3, 3 goes into 4 once with a remainder of 1. So the modulus, again, is remainder after division. So the result is 1. This would be 4 raised to the third power. And then the round down to whole number division or floor division. So 1 as opposed to 1.3. So anyway, you'll get used to using mathematical operations with Python, either with variables or with numbers or whatever. It's very common, and so you'll get really used to it. And actually, this type of syntax is actually pretty similar for most programming languages. So this would look pretty similar if you were using like JavaScript, for example.